I am going to redo my physics road test, my Python road test. So I did a video on this, I'll link it down below, and I just wanted to practice making lists in Python so that we could use them for finite difference method. And then I thought, well, I use GlowScript or WebVPython, whatever you want to call it, and I love it. But you can do these same things in real Python using numpy and numpy. I'm going to say numpy, and I'm not going to stop, and you can't make me. And so I want to just do the same things, right? See, so you can see the difference because there is a big difference. So let's look at this first question. It says make a list of x values from 0 to 2 with the spacing of 0.2. I'm going to show you the way you do this in WebVPython, which I did before. Make this bigger. That's good. So in WebVPython, we have lists, and I can add values to my list, and that's what I did right here. I made a list called x, and then I moved my x values, had a temporary x value, I moved it ahead, and I added that to my list, and that was it, and it worked. Now in real, I hate to say real Python, but I mean it's kind of like real Python. Let's do this in real Python. I'm using Jupyter Notebook. You could do this in Google Colab is really nice to use too. So if you're not familiar with Jupyter Notebook, it's really nice in that you can run Python in these cells, and each cell, you can rerun and stuff like that. It's got all these really cool things, but let's just get to it. The first thing I'm going to want to do is to import some modules. WebVPython has these already in there. It's not real Python anyway in WebVPython. It's just awesome. Okay, so I need to import numpy and matplotlib to make graphs. So let's do that. Import numpy as np. Import matplotlib.pyplot as plt. And that's just what everyone does. Everyone runs it, imports those same things, and that's fine. Okay, I could go through my values, but in with numpy we have these things called arrays, and they're awesome. Okay, they're better than lists. So let's just make an array from 0 to 2 of step size 0.2. I will call this x. np. Now remember, in real Python, we have to say what module we're using this. We're using this from the numpy module. np.arrange, and I always spell it wrong. I always put 2 r's in there, but it doesn't have that. From 0 to 2, a step size 0.2. Let's call this actually, I'm going to call a is 2, dx is 0.2, just because we had that before. X is going to be np.arrange from 0 to a dx, and I'm going to print that. And I have a large step size, so it doesn't get too bad. Print x, run that. And you see, we get something that looks like it's right? 0, 0.2, 0.4, 0.5, but it only goes to 1.8. It doesn't include that last element. If I want to repeat this exactly the same way I did before, I'm actually going to have to add in plus dx. Right, so I don't want to go from 0 to 2. I want to go from 0 to a little bit more. And now it has that 2 in there, and that makes me happy. Okay, there's another way to do it that's very common with Python people, and I'm going to just make a new variable, call it x2. And that's by saying, let's just use the linspace function. Suppose I want to break this into 10 pieces, so n equals 10. Then I can say x2 is np.linspace, and I want to say, well, where do you start? 0. Where do you end? 2. And how many parts do you want? N. Let's print x2. And you'll notice I get something a little funky. It's a little funky because it goes 0 and it ends in 2, and there's 10 spaces, but it's not what I want. It's not 0.2, 0.4, 0.6. Because if I include those 2 end spaces, 0 and 2, then I'm going to have 10 spaces, but I have 11 numbers, right? I need 11 numbers. So I can fix this by saying n plus 1. And now I got the same thing. Yay. Got it. Physics road test question number 1 done. Make a list. This one's really easy. Make a list of function values. I'm going to make a function as a list such that a is x, f is a sine kx. Okay, so let's pick, and then I put the boundary conditions there. So this k is going to be pi over a. So we can just put that in there. Right down here, a equals 1, k equals, now pi is not built into numpy, so you have to say np.pi divided by a. Now I can calculate my function f. I can write it. This is going to be amazing. Watch this. F equals a times np dot sign. Again, sign's not built in. K times x. And I'm going to print that. See, you don't have to go through the list. Since this variable x, that is an array, so I can treat it just like a variable. And numpy's like, I get it. I know what you're doing. I see what you're doing. That's cool. Let's just do it. And so that's really nice. I don't have to do a loop or anything like that. It's all built in there. It just says, okay, I can calculate that. Now, if you don't have the same, if you use more than one variable with different sizes, things can go bad. But I only have one right there, so it all worked out fine, right? It's pretty cool. That was pretty easy. And you're thinking, why would anyone ever use GlowScript or WebVPython? And I think you know the answer, but just to repeat, it's because, one, it's all online. You don't have to install anything, and we have visual aspects. It's good graphing. And I don't like using some of these modules that just solve everything for you. I like to get in there and do the dirty work. That's why I like it. Okay. Next road test question. Plot f versus x. Okay. That's not too hard. Plotting, I don't really like plotting in matplotlib, but we can do it. This is the easiest way to do it. plt.plot xf. I know that's like, whoa, is it really that easy? And yes, it is. And then if you want to make it pretty, there's a bunch of things like plt.grid. I like that. plt.xlabel is x. plt.ylabel is f. And then, I mean, it's a little bit nicer, but still, this is super powerful graphing. Super powerful. But I still like the WebVPython better. And again, we didn't have to go through a loop. I just say, here's my stuff. Do it. I like that. Got that one. Make a new list called f2 and set it equal to fx. Okay, so here we have the same problem. If I make a list or an array, this is an array, and I set the f2 equal to f, it's going to be pointing to the same place. So if I change one, it changes the other. And that may be not what I want to do. And in fact, that's not what I want to do. There's a couple ways you could do this. I'm just going to show you the easy way, and I'm not really going to explain it because, just because. So I'm going to say f2 is equal to, if I just do f2 is equal to f, they will always be the same. If I change one, it changes the other. If I do this, I'm actually saying go through the whole list of f and make that f2. And not make the two things point to the same place. So let's do this. Let me show you f. And I'm going to print f equals f. And then I'm going to print f2 equals f2. So there's my two values. They're the same, right? They have the same last number. Now let's go up here, and I'm going to say f2 0 is equal to 10. Just change that first element in it. So I'm changing f, but you'll notice that f2 changes too. So f is now not 10. Oh, I printed it, and then I printed f2. But you see f2 is 10 right down here. So it changed both of them. Now if I do this, f2 is equal to f colon, that goes through each element, and it won't change f2. It will just change f. So now f2 changed. Oh, that did not work. Bummer. f2 is f. It did change it. I don't know what I'm talking about. Okay, let's do that. Well, this is you learning, right? We can do this. For I in range, this is the way I do it in GlowScript, length of f. Let's make, let's just say, I guess I gotta make f. Let's make f. This is way too complicated. f2 is an np dot arrange from 0 Let's do linspace. Linspace 0 to 2 n plus 1. So now it has the same size. Now when I go through it, I can say f2i is equal to fi. And that should work. And then let's print that. Print f2. Okay, that's, oh, it's still 10. Why is that 10? See, it's 0 right there. Rerun this. 0. Rerun this. Why would that be 10? Okay, now it's 0. I don't know what was happening. Maybe that other thing did work. Okay. That's fine. Let's call that one check. I'm not great at numpy. You know that, right? Okay, this one's really great. Find the integral of fx dx from 0 to 2. And so in WebVPython, we actually have to go through and sum up all the pieces, which I like. I like doing the nitty gritty. I like that part, right? But here we have something very simple. So I'm going to go over here. Let's say I already have dx. I can just say I equals np.sum f2 times dx. Print I. And that's the same thing, right? Now, that does include that last data point where I talked about when you integrate, you have these one less box and you do have points, but it doesn't matter because that last point 0, and if you have a large number of points anyway, it wouldn't really matter. So that's that. I'm not going to do the last one, but here I want to change f2 so that the integral is 1. This is again pretty easy. Watch this. f2 equals f2 divided by I. Right? If I divide f2 by that I, I'm normalizing it. Now when I integrate, let's just say a equals np.sum f2 times dx and print. Oh, I don't want to do that a. Let's call it b, even though it would be fine. And then print b. It should be 1. It worked. Okay, then the last question then there was to make an animated graph, and I don't really do that very well in Matplotlib. Animated graphs are super great in WebVPython, and it's one of the reasons that I love it. Only just one, because there's a whole bunch. Okay, so that's just a comparison test, just so you can see how it works. There are some things in real Python that we have to use. If you remember, I had to solve matrix eigenvalue problems with the matrix. You really can't do that in WebVPython. Although one day I want to build my own module to do that. But there you go. Hope that helps. I'm still here, but I'm stopping now.